Alright, so following some of your doubts, here we are. The following diagram shows a circle with center O and radius 3 centimeters. Points A, B, and C lie on the circle. And OAC, so this angle here, is 1.3 radians. Letter A. Find the length of arc ABC. Well, I've put here the equations that you have at your disposal in your booklet, which might help you solving this problem. So if you observe carefully, you've got length of arc, right? However, you've got two possible equations, right? Now, one of them is when your angle is measured in degrees, and the other one when it's measured in radians. You learned in class how to convert between those. However, during an exam, you're not expected to do so. So you can just fetch the equation that you need and use it. So in this problem, you've got 1.3 radians. So your angle is measured in radians. So we'll go for this equation. So the length of the arc will simply be the radius multiplied by the angle if the angle is in radians. So this would be 3 times 1.3. Since the radius is in centimeters and your angle is in radians, your result will be in centimeters. So very simply, I wouldn't even need a calculator to do that, but we can just avoid any mistakes, right? So 3.9, right? Just so far so good. Now find the shaded area of the region. So now you're looking for, the area of the shaded region. So we're looking for the area which is filled in here, and it's not the slice that we have cut, it's the opposite. So if you cut a pizza, right, if you cut a slice of pizza, and you want to know, okay, how much of the pizza do I have left? So there's more than one way to solve this. What I'm going to do, and I would say that it's the easiest way, is to subtract two areas. So we would calculate the area of the whole circle and subtract the parts that we have here, just because we know this angle. We could, however, measure this angle and just to use the same formula for that angle. If we compare the values, they should be the same. So what would be the area of the full circle? Pi r squared. Since our radius is 3 centimeters, this will be 9 pi. And I'll leave this in terms of pi. I'll call this AT as total area. Now, let's call this, I don't know, A1. So this is A1, and let's call this simply A. So A1 would be the area that we want to find, right? So here, okay. So the area, we can use this equation here because we've got our angle in radians. So area would be half r squared theta, which is 9, and in this case the angle is 1.3. So let's get back to our calculator and let's do 9 times 1.3 divided by 2. So 5.85. Now the area that we want to find would be simply the subtraction of those two. So I would take 5.85 out of 9 pi. So how much would be 9 pi minus 5.85. And our area would then be 22.4 if we keep three significant figures as we have been doing already. Now the second way of solving this, I'll use a different color. We would instead find this angle and use that angle with the same formula that we have used. So let me make a tiny space here. So alternatively, how much would that angle be? Well, if the full angle is 2 pi, the angle that we're looking for here, I'll call it theta, it would be 2 pi, and we would take away 1.3. That is our angle. So if we work those values, 2 pi minus 1.3. Oops. Forgot the multiplication sign. There we go. So it would be 4.98. And remember, you wouldn't necessarily use this number when you carry on. Otherwise, if you use this one, you might have some rounding errors that will be problematic. So what I would suggest is that you follow using this value that you have in your calculator by typing the answer button. So the area would then be half r squared theta, which is half 3 squared times 4.98318 and so forth. So if we put that here, so do 0.5, which is a half, times 3 squared, which is 9, times 4.98, and that should give us 22.4 if we keep this up to 3 significant figures. So we got the same result, which is, well, a good sign that what we have done is right.